Hello everyone, in this video I'm going to talk about how to find a summary route from a number of networks. Let's first look at the purpose of summary route. A summary route is a network address that represents a bigger network which includes all of the networks that you want to summarize. And a summary route reduces the routing table size, and when the routing table size is smaller, that means the routers can exchange routing information more efficiently. There are certain conditions to be able to include a number of networks into a summary network or a summary route. The first condition is that the IP address range of all the networks that you want to summarize must be continuous. For example, the network addresses 192.168.4.0 and 5.0 and 6.0 and 7.0. All these four different networks can be summarized because the IP range starting from the lowest IP address up to the highest IP address are continuous. Let's go into a little bit detail. The first network is 192.168.4.0/24. That means the IP address range in this network starts from 192.168.4.0 and goes up to 192.168.4.255. And what are the IP addresses in a given network? How do you calculate that? That information you can find in another video. The last IP address in the given network is in the last network, which is 7.0, and the last IP address is 192.168.7.255. Now look at this IP address range. The lowest is 4.0, highest is 7.255, and all of the IP addresses in between are in these four networks. So the IP addresses in all these four networks are continuous, and the first condition is met if we want to summarize these four networks. Let's take another example. Let's say we want to summarize these three networks: 192.168.4.0, 5.0, and 7.0. And you can see that these three networks cannot be summarized because the lowest IP address is 4.0 and the highest IP address is 7.255. However, the IP addresses that starting from 6.0 and up to 6.255 are not included in these three networks, so we cannot summarize these three networks, okay, because it doesn't fulfill the first condition. The IP addresses starting from lowest up to the highest that we want to summarize as one summary network are not continuous. The second condition for our summarization is that when you do route summary, the summary route should include only the IP addresses of the networks that you were summarizing and not include any IP address that is not part of any of those networks. Let's consider the following four networks again: 192.168.4.0 and up to 192.168.7.255, and it has four networks. Now the second condition, which says the summary route should include only the IP addresses that are in these networks that you want to summarize. The summary route of these four networks will be 192.168.4.0 /22, and other words, the network address 192.168.4.0/22 includes all and only the IP addresses of the above four networks. If you look into the detail of all the IP addresses that you can have in the summary network 192.168.4.0/22 are /22 will be 192.168.4.0 and goes up to 192.168.7.255, and these are the networks that we want to summarize, they represent the network address 192.168.4.0/22. Now again, if we want to find out what are the network address, what are the IP addresses in a given network, such as 192.168.4.0/22, please take a look at the other video which says the IP addresses in a, how to find the IP addresses in a given network. Right. The third condition of root summarization is that if you take a look at your summary root, the jump of that summary root must be a power of 2, and the summary network must be a multiple of jump. Let's consider these 4 networks again. The lowest IP address is 192.168.4.0, highest IP address is 192.168.7.255. Now the summary root of these networks is 192.168.4.0/22, and okay, I'm gonna pause this video and I'm gonna come back with the more content. Next, let's calculate the summary root for a given number of networks. So first you need to convert all of the network addresses into binary, but you can escape the octets that are exactly the same in all networks and focus on the octet that are different. So in this case, the third octet are different in all 4 networks. So convert the third octet into binary 4, 5, 6, and 7. Then on this octet, look at the bits that are exactly the same in all of these networks. So if you look from the left side, the first 5 zeros are the same, and then next one is also the same, but the 7th bit is not the same. It has 0 on the first network, 0 on the second network, 1 on the third network, and 1 on the fourth network. So the 7th bit is not exactly the same, but on the leftmost 6 bits are exactly the same. Also, the first octet will be exactly the same, second octet will be exactly the same. On the third octet, we see that the first 6 bits are exactly the same. Now this gives you the subnet mask of the summary root. The subnet mask will be the number of bits that are exactly the same in all networks, which is the first 8 bits, the second 8 bits, and the next 6 bits. So the subnet mask becomes 8 plus 8 plus 6, which gives us /22. Even though our original network had /24, when you combine these 4 networks, your subnet mask changes, and the new subnet mask will be the same as the number of ones, and the new subnet mask will be the number of ones for which the number of bits are exactly the same in all networks. Alright. Next, the third condition for root summarization is that in your summary root, if you calculate the jump in the summary root, then it must be a power of 2, as well as the summary network must be a multiple of jump. So let's consider the 4 networks that we used before: 192.168.4.0/24, 5.0/24, 6.0/24, and 7.0/24. Now if I write down the IP address range in all of these 4 networks, you see what the range would be. Now the summary root that we calculated before was a 192.168. The summary root that we calculated before was 192.168.4.0, which is the lowest IP address in all of these networks, and then the subnet mask was /22. Now if we calculate the manually, if we manually calculate the next network address, which would be the very next IP address after the highest IP address in all this network, then that would be the next network address. So potentially the next network address would be the IP address after the highest IP address of all these networks is 192.168.7.255. That's the highest IP among all these networks. So the very next network address is likely to be 192.168.8.0, and you know that the jump is the gap between two networks. That is, if we make a summary root of 4.0 and the next network is 8.0, the jump is this 8 minus 4, and the reason is that the jump is the number of IP addresses, and you know that we use jump to calculate the next network address. Now I'm using in a reverse order. We are calculating the next network address first and then finding the jump here, which is 8 is the next potentially next network address, and this summary network will be 4.0. So the jump is 8 minus 4, which is 4, and the third condition is that the jump of the summary network will be a power of 2. 4 is a power of 2, as well as the second part of the third condition is that the summary network must be a multiple of jump. Our summary network is 4.0. This 4 is a multiple of jump 4. So the third condition is also met in this example. Let's take another example where we try to make root summarization or a summary network from 4 different networks. The networks are 192.168.4.0/23 in this case, and 6.0/24, 7.0/24, and 8.0/24/23 is not a mistake. I'm taking this example. So 4.0/23, from this network address, we can say the range of IP addresses in this network will be 192.168.4.0 and goes up to 192.168.5.255. The next network range is from 6.0 to 6.255, the next one 7.0 to 7.255, and the last one is 8.0 to 8.255. Now if you are not sure how to calculate this IP address range in each network, again there is another video. Please take a look at that video. Now we want to make a summary root, so we convert all these network addresses in binary and focus on the octet that are not exactly the same. In this case, the third octet. 4 converted to binary, 6, 7, 8, all these numbers converted to binary, and then you look in this binary number, which bits are exactly the same in all of these network addresses. You can see the first 4 bits are exactly the same, they're all 0. Our subnet mask for the summary root should include the 4 bits. So the potential summary network will be the network address will be the lowest IP address, which is 192.168.4.0, and the potential subnet mask is /20, which comes from first octet 8 ones, second octet 8 ones, and the third octet 4 ones, because they are exactly the same values. Potential subnet mask is /20. Now let's take a look if this if this summary route meet all the conditions. The first condition was all of the IP address range should be continuous, starting from the lowest IP address up to the highest IP address. The lowest IP address was 192.168.4.0 and the highest IP address is 192.168.8.255. Yes, these networks do meet the first condition that the IP addresses in all these networks are continuous. The second condition for route summarization was the IP addresses of the summary network includes the IP addresses the candidate networks only and does not include any IP address that are not part of any of these networks. So you can see that the second condition is also met. The third condition for route summarization was that the jump of the summary network will be a power of 2 and also the summary network address is a multiple of the jump on the octet where we calculate the jump. Now if we make a candidate subnet mask as /20, then this /20 is equivalent to 255.255.240.0. Then the jump is 256 minus 240, which is 16. /20 gives us the jump as 16, so the summary network cannot be 4 on the third octet. It should be a multiple of 16. So either it can be 0 or it can be a 16. But our lowest network address of all the networks is 4.0. So it doesn't match the requirement of the third condition, and so we cannot summarize all these 4 different networks. Now let's think about another candidate summary route for these 4 different networks. The candidate summary route is 192.168.0.0 and the subnet mask is /20. Now again, if the subnet mask is /20, that gives us the jump as 16 because /20 is 255.255.240.0 and 256 minus 240 is 16. So the jump is 16. So the network address could be a multiple. So the network address has to be a multiple of 16 for the summary network, and 0 is a multiple of 16 or 16 is a multiple of 16. If we take 0, then this summary network includes the IP address from 192.168.0.0 and also 192.168.1.0 and all the IP addresses from 0.0, 1.0, 2.0, 3.0, all of them get included in the summary network, but they are not part of the networks that we are trying to summarize, so it violates the second condition of summarization. This is not a summarization. Let's take another example. How about we try to summarize these 3 networks, which is 192.168.4.0 is /23, 6.0 /24, 7.0 /24, and we excluded the network 8.0 /24 from our previous example. So if we convert the third octet, which is variable in these 3 networks, we get equivalent binary, and we find that the first 6 bits are exactly the same in all these 3 networks. If the first 3 bits are exactly the same, then the candidate subnet mask will be first 8 bits on the first octet, second 8 bits on the second octet, and 6 bits on the third octet. So that gives us /22. And the candidate network address is 192.168.4.0 because that's the lowest IP address in all of these networks. So the summary network is 192.168.4.0 /22. Now let's check if this meets all the requirements. The first requirement was that the IP addresses in these all networks are continuous. Yes, they are continuous. The first network includes the network, all the IP addresses starting from 4.0 and goes up to 5.255. Second one 6.0 to 6.255. Third one 7.0 to 7.255. The second condition was that the summary network should include only the IP addresses that are within the networks that we want to summarize. And if we look at the summary network, then its IP address range is then its IP address range starts from 192.168.4.0 and it's a /22. So jump is 4. So the next network address is 192.168.8.0. So the last IP address of this 4.0 network should be 192.168.7.255, and that's exactly the last IP address of the third network. And we see that all IP addresses of the summary network are coming from these 3 networks, so the second condition is met. Okay, the third condition was that the jump for the summary network should be a power of 2, and the summary network address itself is a power of jump. And we see that the jump in our case is 4 because /22 means 255.255.252.0, and the jump is 256 minus 252. It is 4. So the summary network address that we got here is 192.168.4.0, and the subnet power /22 made the third requirement, which says the jump should be a power of 2, and the IP address of the summary network on the octet where we calculate the jump is a multiple of jump. So jump is 4, and multiple of 4 are 0, 4, 8, and so on, and our summary network is 4 on the third octet, so it meets the third requirement. We could summarize all these 3 networks. Now let's take a look at how we can apply root summarization in a network. In this example, I have 2 sites with 4 networks as shown in the diagram. And network 1 has about 500 users, network 2 500 users, 3 500 users, and network 4 has about 1000 users. How can we design this network so that we can apply root summarization? Based on the requirements, the network that we decided are as follows. One network with 1000 user support we can have is like 172.16.0.0 with /22, and 3 networks with about 500 user support can be like 172.16.4.0/23, 6.0/23, and 8.0/23. Now it's obvious that the first network supports 1000 users and the network 4 needs 1000 users, so we should attach this first network 16.0.0/22 to network 4. However, all 3 other networks support 500 users, and we have 3 other networks that we need 500 users. Now the question is, which of these 3 networks we should attach to which network as in the diagram, because each of these 3 networks support 500 users and each of these 3 networks on the diagram they need 500 users. Can we just randomly assign them, or we should make some strategies that can benefit us in terms of root summarization? So let's take a look which networks we can summarize. So out of these 4 networks, if you apply all the conditions for root summarization, then you will see that we can summarize this 172.16.4.0 network and 172.16.6.0 network, these 2 networks, as 172.16.4.0/22. Alternately, we can summarize these 3 networks, 172.16.0.0/22, 4.0/23, and 6.0/23, as 172.16.0.0/21 network. we cannot include the last network, which is 172.16.8.0/23. Now, according to the topology that we have in this diagram, we see that as we can summarize these three networks, we should assign these three networks that can be summarized into site 1 network. So the first network address 172.16.0.0/22 goes to network 4 because that is the only network that has 1000 users. The next two networks should be assigned in network 2 and network 3 in the diagram, and the last network should be assigned to network 1 in the diagram. And the reason is that all these three networks can be summarized in one network, and that can benefit us the routing table of the site 2 router. Let's take a look at the routing table entry of site 2 router. 16.0.0/22, go to S00 interface. This is a 00 interface. So if this router needs to send a data packet to 172.16.0.0/22 network, which is assigned in network 4, this router must send the data packet to S00 interface. Also, if this router wants to send a data packet to 4.0 network, which is assigned in here, it should send the data packet to S00 interface. And if it wants to send a data packet to 6.0 network, then it needs to send the data packet to S00 interface. The fourth network, 8.0, is connected to an Ethernet cable. So to be able to send data packet to 8.0 network, it should send the data packet to this F01 interface. So this routing table will be constructed based on the current network, and there is no route summarization. If we do route summarization, then the number of entries in the routing table can be reduced. So we can get rid of 2 routing table entries, and we can put just one entry for the 3 networks on site 1 in the routing table of site 2 route. We can put the summary route, which is 172.16.0.0/21, and the interface is 00. That means if this router needs to send a data packet to any of these networks on site 1, which includes all of these 3 networks, it needs to send the data packet to S00 interface. We don't need to explicitly mention each of these 3 networks. The summary network includes all of these 3 networks, so we can say to send a data packet to this bigger network, which is the summary network, the router should send the data packet to S00 interface. Okay, I hope you understood the application of route summarization. Thank you.